what? Example 1, state the derived unit. State the what? Derived unit and the dimension of the following quantity. And what are they? Number 1, velocity, I, acceleration, I, force, IV, work done, V, power. And what does it say? Solution. I remember that what? Velocity is equals to displacement over time. You remember that velocity is a vector quantity. And that what made it to the vector quantity is because it's what? Displacement over what? Time. Displacement is also what? Vector quantity. Therefore, divided by time will give me velocity, which is a vector quantity. And displacement is same thing as what? Distance covered in a specific direction. Distance covered in a specific direction over time. Then again, when I say velocity V, which will represent with V, is equal to what? Distance over time. And what the unit of distance is meter. The unit of distance, which is the fundamental unit of distance, is what? Meter. And this fundamental unit of time is what? Seconds. When I see that velocity is a combination of what? Two fundamental units, which is what? Meter and what? Seconds. And the dimension of meter is what? Capital L. Dimension of the meter is capital L. And dimension of time is what? Dimension of seconds is capital what? T. Remember, dimension of seconds is capital T. And this give me the dimension to the what? LT minus 1. Someone will ask, how did I get LT minus 1? You remember that in your indices, in the indices it said A1 raised to power 1 over A is same thing as what? A raised to power minus 1. Therefore, if I have now L over what? T is same thing as what? L over what? 1 times what? 1 over what? T. This is same thing. Therefore, this L divided by 1, are you watching what I'm talking about? L divided by 1 will give me what? L times this become 1 over what? T, which is same thing as what? T minus what? 1, and that give me what? LT minus 1. That's how we get that. Then now, I can now say, therefore, the unit is the unit of what? Velocity is what? Meter per seconds, meter per what? Seconds, and the dimension is what? LT minus. That's my answer. The unit is what? Meter per seconds, and dimension is what? LT minus 1. Then I, acceleration. What is acceleration? Acceleration is what? Change in velocity. Therefore, acceleration is a vector quantity due to what? Change in velocity is a what? Vector quantity over what? Time. Therefore, acceleration is a what? Vector quantity. Then we say acceleration is change in what? Velocity over what? Time. And that give me what? Velocity over what? Time. And this can be written as velocity divided by what? Time. Then this means what? Velocity divided by time, which is something as velocity divided by time. And what's the unit of velocity? Meter per seconds, which we have already said. The unit of what? Velocity is what? Meter per what? Seconds. And divide by what? Unit of time, which is what? Seconds. Unit of time is what? Seconds. Therefore, I can now write this to the what? Meter per second, which is for velocity, divided by what? Seconds over 1. Seconds, the unit of time is what? Seconds over 1. And the second divided by 1 is same thing as second, because anything divided by 1 is that thing. Therefore, this is same thing as meter per seconds times inverse. This one will come up and this seconds will come down. Then multiplication will apply. Why this remain as it is? These people will what? Invert. And multiplication what? Apply. Remember? Therefore, this m times 1 will give me what? M. And the x, which is seconds times seconds, will give me seconds square. Seconds times seconds will give me what? Seconds square. Why? Meter times 1 will give me what? Meter. And these can be written as what? Meter seconds square. That means meter per second what? Square. This means what? Meter per second what? Square. Meter per second square. That's what it is. And this same thing as what? Meter seconds minus what? 2, which means what? Meter per second square. And somebody may ask, How did I get text? How did I convert it? The same thing we do here, which is in this is said, can you look over here that 1 over what? A raised to power what? N is the same thing as what? A raised to power minus what? N. Therefore, this can be written M over what? X what? Square can be written as what? M over 1 times what? 1 over what? X raised to power 2. And this implies that what? 1 M times what? X raised to power minus what? 2. And that give me mx minus what? 2. That's how it is. And that's what we mean by that. Then now, we go over that. Then here, I have meter per what second what square, that's what it's called. And this give me meter per what second minus 2. And this, the dimension of meter is capital L, and dimension of seconds is what? Capital T minus what? 2. That's the dimension of what? Acceleration. So the dimension of acceleration is what? Capital Lt minus 2. While derived unit of acceleration is meter per second. Therefore, the unit is what? Meter per second. Either you write it this way or this way. That's the unit of what? Acceleration. This unit is called derived unit because it's a combination of two fundamental units, which is meter and what? Seconds. Therefore, it's a what? Derived unit. It's a combination. And this dimension is what? Capital L T minus 2. That is the dimension of what? Acceleration, which we have done here. We come to what? Force. And we said what? We define force. Before I can get the unit, I must define the what? Substance. You know what we are doing? Then force. What is the force? Mass times what? Acceleration. Force. Apply force on a linear force. We have a linear force. When I talk about force, I'm talking about linear force. When we talk about torque, we are talking about what? Circular motion. In a circular motion, we talk about torque. We don't talk about what? Force. We talk about torque. Torque and what? Force are the same, but torque is being applied in a circular motion, while force is in what? Linear motion. We say force, which is represented as what? F, is equals to mass times what? Acceleration. Mass times what? Acceleration. And this will give me what? M times what? Acceleration, which is what? Mass times what? Acceleration. And what's the unit of mass? This is what you use to represent mass, M. And the unit of mass is what? Kilogram. That's the unit of mass. That fundamental unit of mass is what? Kilogram. Can you see here? Then times. Then what is the unit of acceleration is what? Meter per second square. That's the unit of what? Acceleration. Meter per second square. While the unit of mass is what? Kilogram. Then this times this. And this can be written as kilogram over 1 times what? Meter per second square. And this will give me kilogram times meter will give me kilogram meter. And 1 times second square will give me second square. And this can be written as what? Kilogram meter per second raised to power minus what? 2. You remember? You come over here. This is what we did. Revising it will give you minus what? 2. Therefore, I said what? Kilogram meter what? Second what? Minus what? 2. And this is equals to dimension. What is the dimension of kilogram? Is capital M, which is the mass. The dimension of kilogram is what? Capital M. Dimension of meter is what? Capital L. And dimension of what? Seconds is capital T minus what? 2. And that's it. And I said the XI unit. Remember, the XI unit of force is not what? Newton. This is in a memory of what? Newton, which is discover what? Force. The SI unit of what? Force is called what? Newton. Newton is the name, as if Newton is the name of the person that discovered what? Force. And we use this to remember him. So we said the unit, SI unit of what? Force is a what? Newton, which is capital N, which we use to represent what? Newton. Why its dimension, why its derived unit? Why its derived unit is a what? Kilogram meter per what? Seconds square. Kilogram meter per second what? Square. That's its derived unit. And from its derived unit, we get its dimension. And we say that dimension is what? Capital M for what? Kilogram. And capital L for what? Meter. And what? T minus 2 for what? Seconds per second square. Then you remember that I can only get a dimension from what? The derived unit. And I can only get derived unit when I have defined the quantity. I can't be able to get derived unit without defining the quantity. You remember, I first of all I define acceleration by knowing that acceleration is change in velocity over time. I'll be able to know the what? The derived unit. And from the derived unit, I get my what? Dimension. You see that I cannot get a dimension without knowing the derived unit. You noted it. We cannot get what? Dimension without knowing the derived unit. Without knowing the definition, I can't get the what? Derived unit. Therefore, I'll first of all get the definition of a quantity before I can get its what? Its what? Derived unit. And from its derived unit, I get its what? Dimension. Do you get it clear here? I can only get a dimension from what? Derived unit. And I can only get derived unit from the definition. What I don't know, I can't get is what? Derived unit. I will first of all define it. From its definition, I will get his what? Derived unit. And from its derived unit, I get what? Dimension. Have you seen the sequence in move? Therefore, we have seen this. Let's see the next one. Yeah. Note that we get dimension of derived quantity from its derived unit, not from its xi unit. We don't get derived units or dimension from what? Xi unit. You see that xi unit of force is different from its what? Derived unit. Xi unit of force is nothing but what? Derived unit of force is what? Kilogram meter per second square. Then now we come to IV, work or work done. Either we call it work or work done, which we represent with what? W. Work done or work is represented with what? W. We said is equal to force times distance covered in a direction of force. Look at it. I said work done is a force times distance covered in a direction of force. Covered in what? Direction of what? Force. And we say that what? This give me what? Force times what? Distance. And what is force? We remember that force, which we have defined, is what? Mass times what? Acceleration. This force is mass times what? Acceleration. Look at it. Is mass times what? Acceleration. That's what? Force. Then now, what's the distance? Look at the distance. And I remember that this can be written as mass times what? Acceleration times what? Distance. And what is the unit of mass? Is kilogram. What is the unit of acceleration? Meter per second what? Squared, which we have already defined. Then what's the unit of distance? Meter. And this can be written as kilogram over 1 times meter per second what? Squared times meter over 1. That's how we can be able to write this. This can be written as a fraction kilogram over 1, which is same thing as kilogram, times meter per second square, which is this, and the meter over 1, look at the meter over 1, which is same thing as what? Meter. And now, this and this will give me kilogram meter, then times this will give me what? Kilogram meter squared over what? This and this will give me what? Second square, times 1 will give me second what? Square. And I will have what? Kilogram meter square over what? Second square. And this can be written as kilogram meter square seconds what? Minus what? 2. Remember, I have explained it. We said kilogram meter square over what? Second square. And that's what we call kilogram meter over what? Kilogram meter per second what? Square. This is explained as what? Kilogram meter square per second square. Kilogram meter square per second square, and that can be written as this way. And now dimension. I know that dimension of kilogram is capital M, and dimension of what? Meter is what? Capital L, and that gives me capital L squared because the meter here is squared. Then removing the meter, put L, I will have what? L squared. This is seconds. Dimension of seconds is capital T. Removing the what? Seconds here, putting T, I will have T raised to power minus what? 2. And that gives me the dimension of what? The dimension of work done. Of what? Work done. Then let us go there. So therefore the SI unit of work done is what? Joule. Have you said it now? The SI unit of work done is what? Joule. Are you gonna say that? The SI unit of work done is what? Joule. And why its derived unit why its derived unit, look at here, why its derived unit is what? Kilogram meter squared per second square. Derived unit is what? Kilogram meter squared per second what? Square, which can be written this way. And its dimension, which we have already done, and its dimension is what? Capital M L square T raised to power minus what? 2. That is what? Dimension. I can now go to what? V, which is what? Power. I go to power, we say power is what? P, and we say that what? Power is the rate of what? Displacing what? Energy. And you remember that energy is the ability to do work. Therefore, the energy is same thing as what? Work done. We are saying power is the rate of what? Displacing what? Energy. And we cannot say that energy is the ability to do what? Work. Therefore, energy and work are the same. When we talk about work, we are talking about what? Energy possessed. When we are talking about what? Energy possessed, we are talking about what? Work to be done with that what? Energy. Therefore, we say that what? The unit of what? Energy and the unit of work done are the same. And when I say that power is the what? The rate of what? Displaying what? Energy. Power is the rate of displaying what? Energy. Then when I come here, the way we use to represent power is P. And we say power can be defined also as what? Is the rate of doing work, which I said before, that energy and work are the same. We said power is the rate of what? Doing what? Work. And hence power is equals to what? Work done, which will represent with what? W over time taken. You know what I mean by rate? Rate mean what? The what? The number or over time. That's rate mean what? Energy over what? Time. That's what? Power. So we now say the rate of doing work, we say work done over what? Time. That's the rate of doing work. Or energy over what? Time, which is what? Rate of what? Dissipating what? Energy. Rate of what? Dissipating what? Energy. Or rate of what? Doing what? Work is what? Power. And that's what we have defined now. Let us go to what is what? Unit and what? Dimension. Now, power. Power is equals to work over time. And what's the work? Work is force times what? Distance over time. Work is force times what? Distance over time. And what is force? Force is what? Mass times what? Acceleration times what? Distance over what? Time. And is equals to what? What's the mass? Mass times what? Acceleration times what? Distance. I have splitted it. Mass times what? Acceleration times what? Distance over what? Time. And is equals to what? What's the unit of mass? Kilogram. What's the unit of acceleration? Meter per second square. What's the unit of what? Distance is what? Meter. And what's the unit of this man? Seconds. Have you seen it? I have started from the up one. What's the unit of what? Mass is kilogram. What's the unit of acceleration is meter per second what? Square. What's the unit of distance is what? Meter divided by what? Unit of time, which is time, is what? Seconds. Have you seen it here? Then I cannot say that this man can be written as kilogram over 1 and times what? Meter per second squared times what? Meter over 1. I cannot say, look up here, I cannot say kilogram times meter will give me what? Kilogram meter square. And 1 times second square times second square again. 1 times second square, then second square times 1 again will give me second square over what? Seconds. And that's what we see here. Come over here. You will now see kilogram meter square over what? Second square divided by what? Seconds. Are you following me? Then let us come here so everyone get it right. This kilogram meter times meter squared over what? Second square divided by what? Seconds. That's what you see here. I think you have said it here. Then coming over here, I want to see that what? Kilogram meter square divided by second square over what? Seconds can be written. You know that this can be written as what? Kilogram meter square over what? Second square. Look at it. Divided. Look at the division. Divided by what? Second square, which is divided by what? Second. That's not second square. Divided by what? Second. This is one entity. This is one entity divided by what? Second. Now I would have said what? Kilogram meter squared over what? Second square divided by what? Seconds. That's what I did here. Then now, coming over here, this can be written as what? Kilogram meter squared over second square divided by what? Second squared over 1. And this can be inverted. Multiplication applied. When the multiplication come up, this one come up and this seconds go down. We now see the word multiplication, see the one coming up and the word seconds go down, multiplication word apply. Remember that this man remain as it is. Then this times what? This will give me what? Kilogram meter squared. And this seconds squared times seconds will give me seconds cube. This one called what? Seconds squared times seconds will give me seconds cube. Look at seconds cube here. And doing that now, I can now say that what this can be written as what? Kilogram meter squared seconds minus what? 3. And that's what we call kilogram meter squared per second what? Cube. Kilogram meter squared per second what? Cube. That's what it is. Then from this derived unit, look at from the derived unit, I cannot get the dimension. You see that I cannot get dimension without getting derived unit. I cannot say the units. The dimension of what? Kilogram is what? Capital M. The dimension of kilogram is capital M. And the dimension of meter is capital L. If I remove the meter, put what? L there, I will have L squared. That's what we see, L squared here. Then removing these seconds, I will put what? T, which is capital T for seconds, and that will give me minus what? 3, minus 3. And that's give me the what? The dimension of what? Power. The dimension of power now is what? Capital M, capital L squared, capital T raised to power minus what? 3. Then I now say, therefore, the units, the SI unit, remember, the SI unit of power is watts. Oh my God. You now see that what? The SI unit of power is what? Watts. Obviously, as I underline it. Remember it. The SI unit of power is what? Watts. Why its derived unit? Can you follow me here? Why its derived unit is kilogram meter squared per what? Second cube. Kilogram meter squared per second what? Cube. Which can be written this way. Kilogram meter squared per second what? Cube. Kilogram meter squared per second what? Cube. And its dimension is what? Capital M, capital L squared, and capital T minus what? 3. That's the dimension of what? Power. And that's our answer here. And when I do that, that's my what? Answer. And that's it.